Hey Honors kids, so this is the second page of the Honors 16A worksheet. We actually did a handful of the ones on the back in class together, so I'm just going to do 11, 13, and 15 just to kind of give you a nice little start. So let's do number 11 first. I lost my sticky. 1 second. So in the last video, we made this sticky note to show you kind of the 3 steps that you're going to go for each problem. So we're going to start by copying our given information, which is that the measure of angle QPR is equal to the measure of angle URP, which is equal to 90 degrees, and also that segment QR is congruent to segment PU. So that's given information. Let's make sure it's marked in the picture. Well, here's the two 90s they talked about, QR, PU. Okay, next step. We've gone through all of our given. We're looking for vertical angles. I don't see any in the picture. We're looking for shared sides. Well, here is a shared side. And I mentioned earlier, I like to use green for all my given, or one color for my given and another color for the things I'm adding, so I know that my reason can't be given. I have to give something else for my list. Okay, so number 2, we want to say that segment RP is congruent to segment PR. Now you could do RP or PR here, it just needs to be the same thing, but the reason I'm doing RP and then PR is because PR lines up with RP. So when we get more into congruency statements in our class or two, that will matter a little bit more, but not too worried about it for right now. Whenever we say something is congruent to itself, that's the reflexive property of congruence. Congruence because that congruent sign. Okay, step 3. We don't have any parallel lines, no shared angles, so we're done with this. So now we're down to the bottom. We have 3 pieces of information in each triangle, so that's also a heads up that we have everything we need before the last step. Remember, the given is always our first statement. The prove is always our last statement. So I know that this is going to go here, but the big thing is I need to figure out which congruency statement or postulate or theorem I need to use to justify why my 2 triangles are congruent. Well, you'll notice I have 2 sides. The angle is not included. It's not directly in between these 2 sides, or if you see these sides, they meet at vertex P. That's not the angle marked. It's up here. So this would be ASS. Because we have an angle and 2 sides. But remember, ASS is no good. We can't use that to prove triangles are congruent. Well, the reason we're okay in this case is because it said when we have ASS and it's a right triangle, we have a special case called HL. Well, we can use HL because we already know that it's right triangles. We have a pair of hypotenuses that are congruent. We have a leg that's congruent to itself. So we have the hypotenuses, we have the leg. So I can use HL to prove that these 2 triangles are congruent. Okay, let's keep going. Let's look at number 13. Now 13 is tricky because we have overlapping triangles. That's where we get these shared angles or sometimes shared sides as well. Let's do this one together. When we do overlapping triangles, we talked in class about how we want to draw them and separate them out. So our 2 are going to be LKN. Here's LKN, and I'm going to redraw that here. Here's L, here's K, here's N. I like to draw it as true to scale as I can. It doesn't have to be perfect, but I find it helpful. Here's LMJ or LMJ. Okay, looks more like this. So here's LMJ. Okay, now we're going to do exactly what we did before. We're going to start with our given information. So segment LJ is congruent to segment LN. Angle J is congruent to angle N. Let's mark it in our picture. So LJ is the same as LN. Angle J is congruent to angle N. If you wanted to put it in here too, this whole thing was congruent to this whole thing. Angle J was congruent to angle N. Now we're back to this list. There aren't any vertical angles for comparing the green and the pink triangle. Like I see these here, but that doesn't help us for this problem. There are parts of sides that are shared, but we need the full side to be shared to use that. We don't have parallel lines, but what we do have is a shared angle. And you'll notice that the pink triangle and the green triangle use this angle L right here. That means that angle needs, well, it's going to be congruent. This angle in here is going to be the same as this here. They're both L, and it uses that whole angle. So what I'm going to do now is I'm going to say, okay, well, angle L is congruent to itself. The reflexive property of congruence is what lets me say that something can be congruent to itself. Well, let's take a look. I have 3 pieces of information here, 3 pieces of information here. Specifically, I have 2 angles and a side directly in between. That's going to be ASA. I have a pair of congruent sides, a pair of congruent angles, another pair of congruent angles. So now I can prove, my last statement is what I'm trying to prove, that LKN is congruent to triangle LMJ. And that's because of angle, side, angle congruence. Okay, let's do one more, because remember I said we've already done a bunch of the back together in class, so let's do 15, and then you need to finish the rest of this worksheet by yourself. I'm only doing the odds because you need to practice coming up with these from scratch on your own. So number 15, we always start with our given information. We gotta make sure it's in our picture, so WX and YZ are both congruent and parallel. Okay, vertical angles, no. Shared side, yes. So segment XZ is congruent to itself. I did the order because XZ and ZX, that's how they line up. You don't have to. If you put XZ, I would give you full credit. It's just a good habit. So we're saying something is congruent to itself, so that's a reflexive property of congruence. I only have 2 pieces of information for each. This parallel doesn't count as one of my congruent parts. I only have 2 sides. So let's go down our list, shared sides. Now we're at parallel lines. I think I mentioned this earlier, but whenever you have parallel lines, if you can draw a Z, so here's a Z, my parallel lines have to be the top and the bottom of the Z, or an N, it might be if it's sideways. The elbows that it captures, so this angle right here and this angle right here, are my alternate interior angles. So I know there's another angle here, but that's not in between the 2 yellow lines. That's the elbow of that Z. So those are my 2 alternate interior angles. Because I've already stated that my lines are parallel, I can say that these 2 angles, so WXZ and YZX, because of the alternate interior angles theorem. So now that I've got my 3 pieces of information, I can say that my 2 triangles are congruent by 2 sides, included angle, that's SAS. So hopefully this was helpful. This video will be good to help you with your homework, but also to help you study for your quiz. Remember, our quiz that's on for honors is going to be on Monday, if you're on Orange Day. It's going to be mostly, if not all, proofs. So make sure you're prepared for that. Use this as a review. Maybe print out this worksheet and try it again to help you study.